This thing is heavy. How's it going, guys? Cass back with another video, and today I'm going over my workstation that I went in and put together. Now, this thing has been quite a endeavor to get working. I want to say I started working on this about a year and a half ago when I first bought the case and had the original vision on how I wanted to put this specific PC together. So a year and a half, that's like a long time for people to put PCs together. But that's usually how I build PCs. I never buy everything at once. I usually pick parts here and there. I have a vision, write this stuff down, and then pick parts when they become available. On sale, I can find a deal on them, and then eventually I'll be able to get what I want. So I'd say I'm about like 95, 98% complete with this. There's only a couple more components that I really want to put in here to fully max it out. But yeah, this is codenamed OptiThreads. Everyone has their kind of like, I want to say, dream PC setup, whether it's for gaming, for work, whatever it might be. Mine was kind of a combination. I wanted a PC that was great at playing video games, any game I want, cranked settings, high fidelity, all that kind of good stuff. I don't have to worry about tuning stuff. And also like a little bit of personalization, a little bit of like water cooling here and there. But I also wanted a PC that was really good at like just cranking out work, really reliable, really stable, a lot of just multi-threaded workload performance. And there's only a handful of CPUs out there on the market, and they're still making compromises to do that. And I kind of wanted like a no compromise solution, at least for me. Um, so I decided to build two different PCs, and I think that's just the best way to do it if you want to have like the best of both worlds. Just get a PC for one workload and then a PC for the other workload. In this case, gaming and then workstation stuff. And I also was a big fan of like sleeper builds, so I'm going to take the side panel off in a couple minutes, but you guys are going to be a little bit surprised by the stuff I was able to cram inside this thing. But yeah, I wanted a workstation and a gaming PC. The WISP workstation is going to be used for like just professional work, video editing. It's going to be used to capture footage when if I want to get into streaming sometimes on my gaming PC. And it's also going to be used for 3D modeling and SolidWorks. Those are kind of like the main couple things. But also if I'm just like browsing the internet, answering emails, just general stuff you would do on a desktop on a regular basis, this is going to be what I use it for. So I don't know if you can see the little badge right here, but it says Ryzen Threadripper. Yeah, I put a Threadripper in this specific PC. When I had this PC, I was looking at like prices on different components, and I saw that the 2990WX, which used to go for like over $2,000, was dropping around the $1,000 to $900 price point if I bought it from a good retailer. This was around the time, I think this would be 2021, fall of 2021. So this is when you had what came out that year. Was that the year that? No, I think that was we already had like Ryzen 5000, Ryzen 7000 was being rumored and whatnot. I think the 12900K came around that time period. But like when these new like modern day consumer grade CPUs were coming out, they were pushing up on the performance of this specific PC in multi-threaded workloads. At least this PC and this CPU in its stock form, I should say. So that was kind of driving the price down. You had newer Threadripper. I think Threadripper 5000 came out around that time period as well. And these were being like resold on the used market for around, like I said, $900 to $1,000. And I thought to myself, wouldn't it be crazy if I could actually get that CPU and like put it in this case and get it overclocked to like 4 gigahertz, which is around like where the Silicon's limits were, 4.0 to 4.1. That was the challenge behind it. I could have bought like a 12900K for less money, for a lot less money actually, a modern system, but that wouldn't have been as fun. I wanted something that would challenge both my building techniques, my thought process, give me something to be a little more creative with. So that was the first challenge, getting that CPU under control, overclocked in a system like this that's relatively quiet, but it keeps it cool, and I can just max out that CPU. Other than that, I have a 3090 installed in here as well. I have 64 gigabytes of memory at the time, roughly 4.5 terabytes of storage, 1,000-watt power supply, and it is custom water cooled. So yeah, from this angle, you really can't tell that it has all that stuff. But let's go ahead and take off the side panel, and you guys will see the madness that went inside this specific PC. So as you can see here, this is the first giveaway, this side panel piece that this isn't stock. I had to modify this because I needed to get my graphics card temperatures under control, especially with the 4090 that can draw upwards of like 400 watts at its max load. So when we take the side panel off, you'll see that it is a little bit of a, complex mess, but it is still pretty clean nonetheless. Get the side panel out of the way, and you will see exactly what goes on inside here. So like I said before, Threadripper based system. We have our 3090 down here. and a bunch of water cooling components. So, first off, the motherboard. This wouldn't have been possible if ASRock was not just complete, like, madmen when they made this motherboard. I think this is the only micro ATX motherboard that is available for consumer Threadripper, the ASRock X399M Tai Chi. Now, why they made a micro ATX Threadripper motherboard, I don't really know. They were able to cram pretty much as much I/O on here that if you wanted to max out all 64 lanes, PCIe lanes that this specific CPU had available to it, you could, but you would literally have to use every single slot on here. So I'm like, if you have like any sort of like dual slot graphics card, you can't max out the lanes on this specific system. So it just doesn't make that much sense, because if you were to make a micro ATX like motherboard nowadays with the modern day Threadrippers and then the Xeon processor where they have like over 100 lanes of PCIe sometimes, there's just not going to be enough room I/O wise just to be able to utilize all of that, if that makes sense. But regardless, they were able to mount and be able to technically use all 64 lanes. I'm pretty sure you have three PCIe X16 slots, and then you have four or three M.2s, all four lanes. So that's 16 times 4. So yeah, that roughly works out to be 64. So this is the only micro ATX motherboard available for Threadripper. I was able to get it on a relatively good deal. I actually bought it on used from a guy on eBay. He had a couple bent pins, so he sold it to me for like $75. That saved me a crap ton of money, because that motherboard on the used market now goes for like $500, which is crazy. 2990 WX, like I said before, I got it for around $750, $800. Got this graphics card for around $600. Power supply around $80, and then the water cooling components about $400 as well. So first, let's go ahead and talk about the water cooling setup. This is why I really like custom water cooling, because it allows you to do really interesting stuff like this. Now, when I water cool, I do it mainly for function and not necessarily form. So you'll never see me using hardline tubing. You won't really ever see me using any sort of like special dyed coolants or anything like that. There will be very minimal RGB, and I'll almost always have quick disconnects in line with the loop just for serviceability. Now you can see why quick disconnects are pretty important here, because without them, taking apart this water cooling loop would be next to impossible. I have 4 in here, 2 right here that disconnect the monoblock from the front radiator, and then the pump res combo at the top, and then 2 more that disconnect the rear radiator from the front radiator and the pump res combo at the top. This allows me to not only remove the monoblock separately to replace thermal paste or anything like that, but I can also pull out the reservoir and also the 2 radiators, all in individual components. So you might be thinking that draining might be a little bit of an issue to drain this loop, but the easiest way to do it is just disconnect everything, pull out the radiators, pull out the reservoir, pull out the monoblock, and just go to like a sink or get a bucket and just empty it there outside the chassis. Kind of the thought process there. So draining the loop is honestly pretty easy. Take into consideration that you do have to dismount the monoblock from the CPU in order to drain it. So you have to replace thermal paste pretty regularly if you want to do it that way, but that's kind of a give and take in this specific setup. Overall, it's much easier to drain the loop this way. All the components I used were a mixture of Bits Power, Alpha Cool, and Hardware Labs. These specific fittings are the TPV line of components for water cooling that Alpha Cool provides. Now, the TPV line is what they use on like their Aurora series of custom AIOs. Their Aurora line is kind of a mixture between a normal AIO and then a custom loop, because you can basically buy one of their AIOs and then expand on it over time, and a lot of the components are standard, G quarter-inch threads, so on and so forth. So you could take one of their pump blocks and then transfer that over to your custom loop if you so choose. Get hardline tubing if you want, or whatever, change out the radiators, so on and so forth, what have you. Now, all the fittings cost me about $100 plus the tubing, which is kind of crazy to think about because it's really inexpensive. The tubing is a little bit on the thinner side. I think it's like an inner diameter of like a 7.5 millimeters. But for a case that this is this small, this smaller tubing definitely does come in handy. Plus, this the rubber tubing they're using here is made for like long-term use, industrial use, if you want to say. So I don't have to worry about like any of the particulates getting into the coolant that you might get with some other silicone tubing that might degrade over time. But yeah, like I said, I got the fittings, the tubing, the quick disconnects, all for around like a little under $100, which is really inexpensive. You can get like a 6-pack of their fittings that are plastic for like $16, and then like $26 will get you their brass fittings. The radiators are from Hardware Labs, so I have a 140 millimeter radiator in the front. It's 55 millimeters thick in diameter, and then a 55 millimeter thick 92 millimeter rad in the back. Now, if you do the math roughly on the fluid capacity that both these radiators have, it comes roughly in between like a 360 to a 420 millimeter AIO nowadays, which in a lot of cases is more than enough to cool a CPU pretty well. Also, I have a res combo. It's a replacement for a 5.25 inch bay at the top. It has a DDC pump in here. This is just to makes filling the loop a lot easier, being able to have like some sort of air in here, that way it can collect at the top. It makes it draining the loop really nice and filling the loop really nice as well. I also wanted to get as much fluid capacity out of this specific case as possible. Because the CPU can draw upwards of 500 watts under load, I wanted as much water in here as possible. That's going to basically delay the inevitable, I would say, before it reaches its max temperature, which in most cases isn't going to be that big of a deal. For the work loads I personally use, I'm pretty much never going to reach the max cooling capacity that this specific case can handle. I looked at the ratings on like the radiators, and it's somewhere close to, I want to say, like 750 watts between the both radiators combined. Around 500 on the front, 220 on the rear, give or take. I'm never going to reach that, but still, having more water in here means you're going to be able to delay the inevitable of reaching that equilibrium point where you reach your max temperature that this specific PC cooling unit can handle. But yeah, that's pretty much the water cooling setup. As far as the graphics card, nothing really had been modified to this. I really had to make sure I found a graphics card that could fit in here properly. I have basically exactly 300 millimeters of length to be able to fit a graphics card in here. Give or take maybe a millimeter or two when everything's like mounted up really nicely in here. But the 3090 was one of the, I wanted a graphics card that had at least 20 gigabytes of VRAM. I was looking at prices of like the 7900 XT and the XTX. If I wanted to run like a reference model cooler, it would be running significantly hotter than I think this even is. But that's neither here nor there, Plus, with the NVIDIA suite, I do prefer that, with the video editing software, being able to use CUDA and whatnot. Not saying I couldn't use an AMD graphics card, but again, this was more VRAM and also cheaper than the 7900 XT at the time, so kind of made more sense to go with this. But yeah, use 3 8-pins. Nothing really to be said about this. I did have to modify. I changed up thermal pads, put on some IC diamond on the cooler as well, just to be able to max out performance. And yeah, it sits in here pretty nicely. One thing to note is that with these cables down here, I zip tied off the expansion cables. They're just the stock cables that come with this power supply. This almost acts as a GPU support bracket, because you push down the graphics card, there's like little to no flex whatsoever. That's because it's like pushed up against these cables down here, being tucked underneath the graphics card. All memory channels are filled with 64 gigs. I will be upgrading to 128 gigs of ECC memory in the future. They're clocked at 2666. I guess I'll take the time now to explain why that is. This kit can go up to 3200, but I noticed that like this specific, Threadripper system, and I guess all early generations of Ryzen were pretty picky with memory. With this specific setup, being able to get 3200 megahertz on your Threadripper system, the 2990, the 2000 series specifically, was a little bit more challenging than you would imagine. And then it's just inevitable that with, the increased capacity, you're going to put more stress on the memory controller to run at certain speeds. So I could run this setup on 16 gigabytes at 3200 all day, every day, like I did when I first built this. But as soon as I tried throwing in 32, where it's now 64 gigs, and eventually 128 gigs, I had to drop the clock speeds down to 2066. And also on top of that, like, in the workloads I use, other than gaming, I suppose, memory, isn't really that big of an issue. Memory speeds isn't that big of an issue. More so capacity is what I was going for with this setup. Plus, I was able to drop the profile on the voltage down to like 1.2 volts, which is stock voltage for DDR4 versus 1.35 overclock voltage. And I saw a significant drop in temperatures and also just a significant increase in stability on the system. And now I know Cinebench is not a good stress test for memory stability, but I did notice, when you're running higher transfer speeds, you have to up the voltage, which means more stress on memory controllers, on the CPU, and so on and so forth. I saw a difference in like 60 watts between running 1.35 volts, 3200 megahertz, and like 1.2 volts, 2666 megahertz. That's a humongous drop in wattage that this thing would draw. It was like 560, 550, and then it dropped to like 490 if I had to like 500 the other way around. So at the end of the day, I'll take the hit on the FPS in some games. This won't be my gaming system moving forward. Like when I get my final gaming PC finished. So I'll just play games on that, and then everything else that I need isn't like sensitive to memory speeds. So drop the clock speeds down and then use it that way. Plus the ECC kit of memory, 2666 is way more affordable than getting 32 gig or 3200 megahertz at 128 gigabytes of ECC memory. That's going to cost you like $550 to $600 on its own. So I'm able to save like $200 there. You know, $398 to $400 is what I saw a kit go for, which I'll probably end up throwing in here, which it just makes more sense. So the only other thing to really talk about, I guess, is the mods I had to do to the case specifically to be able to get everything in here. And I think that'll kind of show a little bit of credence. If you want to do something similar to OptiPlex for any other system, maybe not Threadripper, but just throw any sort of modern hardware into a case like this, what you need to do. Now I'll start with the graphics card because getting this cool was pretty much a challenge. And you'll notice that there really isn't that much space as far as the amount of space in between the side panel and the end of the cooler. Maybe like an inch and a half, maybe like half an inch in all honesty, 15 to 18 millimeters at most, and that's pretty much it. Just enough to get clearance for the 8 pins, and that's it. That's all you got. I noticed that if I was to put the side panel on, I would see at least a 12 degree difference, 12 plus degree difference in the temperature that this GPU would hit, and it would just like increasingly get higher and higher and higher until with thermal throttle, simply because there was nowhere for that hot air to go. It's being blown against the side panel, and it's all being blown against the motherboard, right? Some of that's going to bounce up and maybe get evacuated from the back of the rear fan and then the power supply, but a lot's going to be bounced back down and just be recirculated by the cooler until eventually just thermal throttles, which is not what you want, especially with the 3090 with its memory on the back plate. Memory temperatures were getting really, really high, like in the 90s, which is just way too high. So that's where the side panel comes in. I did modify this to, like I said before, 280mm fans down here, but if I turn it around, you can see the complexity that goes in here. I have a single, extension 4-pin PWM that plugs in right here at the top, so I just unplug this to be able to take the side panel off easily. And I have 4 fans mounted right here, 280mm and then 260mm. These are not 2 60mm. The NFA6s are good for bringing in cold air. This is just another source of intake, fresh intake air that hasn't been already preheated by the front radiator. And then these 2 act as exhaust. So as soon as that axial fan design, as soon as that hot air gets exhausted from cooling the GPU and the memory and everything, it basically gets evacuated from the case immediately. So yeah, active cooling this way, this makes a humongous difference in temperature. And then also these 2 60mm fans also really helped out bring down temperatures on the CPU as well. I think it also might, depending where it's placed in regards to comparison to the top of the graphics card, you might have a little bit of cool air being blown over the backplate to cool down memory. But I think it's more so just being able to exhaust more of that hot air that the GPU produces. That makes the difference in all the temperatures on there. So with the undervolt profile that I have on here, I see a max, the max loads I personally put on this, around like the 70 degree mark under stress test, and maybe like 64 degrees on the core if I'm playing a game, like a pretty intensive AAA game. The memory jump temperature, which is the hottest part of this component, gets at most like 87 degrees Celsius, which is perfect for me, perfect for me. The fans will spin up relatively quickly, and it's going to be a little bit on the loud side, but that's just kind of par for the course. I was thinking maybe D-Shroud mod that might be able to get the at least the noise profile down a little bit on this specific GPU, but we'll have to save that for the future. Yeah, this is a way, just a really nice way to be able to get the airflow pattern in this case optimized for best performance. And I had to 3D print this part right here to mount on the side. So if you want to modify your specific OptiPlex case, I'll just contact me. I might put like a link in the description to the STL file that I used to design this, but yeah, it works really nicely. And then the 60mm fans you can just zip tie to the side. Great for the intake. Works really simple. I had to modify the front panel, both a couple of the connectors, and then also a way to get this radiator mounted to the front. So let's go ahead and take up this front panel, and I'll show you guys that. Comes off pretty easily with a couple tabs you have to pull. And we can flip this around to the front so you can see exactly what's going on here. So the power button. The reason why you want to buy the 3020 is because to wire this up to work with a normal motherboard is very minimal. Just for, I guess, fun fact, there's like the 7000, the 3000, and the 9000 series of OptiPlexes. The 20 or the 10 or whatever you see other that other number after that, that just denotes, I guess, the generation of the OptiPlex, but it'll also like tell you about the generation of like Intel CPUs where there's like a Broadwell or a Haswell or Ivy Bridge or whatever it might be, CPU generation of the i5 or i3, i7 that they put inside the OptiPlex that you're buying. You're not really going to see a huge difference in prices. I bought the 3020 just because it was in pretty good condition. This was a bare bones kit. It came with the motherboard and power supply, but was missing hard drive, CPU, RAM, all that kind of stuff. You can find these cases for like, I want to say $30 to $40, maybe 50, and then full dropout PCs that actually function for close to $90. So really inexpensive if you want to be able to do this yourself. But the first thing you're going to want to modify is the power button. The 30 series, or 3000 series, I should say, is great because the front I/O panels, they are pretty much already set up to where you can all these individual connectors are different. I want to say this, I forget what sensor this is. It might be like a CO, like carbon monoxide sensor, or something like that. But you have a standard HD audio and USB 2.0 header that you can just straight plug into your motherboard, which is a huge help. The 7000 and 9000 series came with USB 3 because the more premium model with the higher end CPUs. But with addition of USB 3.0, they went ahead and combined the HD audio, this little sensor thing, 3.0 and 2.0 USB into one giant connector. Like it was really like almost like a mini 24 pin connector that plugs into the side of your proprietary Dell OptiPlex motherboard. Rewiring that would be an absolute pain. So if you want to get all those functions to work on the front, get a 3020 or 3010 or what have you that only has USB 2.0 because you'll have standard just plug and play connectors. The power button, you can rewire it for either, I rewired it for the power LED and the power button. It has the HDD LED as function as well. I don't know if you want to do that, but I personally didn't. You can just get like those really small connectors, either like on like a breadboard kit you would get from a Arduino, whatever, one of those starter pack things. I had a couple of those like little connectors lying around from because I modify airsoft guns, so some of the connectors for the MOSFETs I was using there were the same pin style to be able to attach to the motherboard. You can find them pretty cheap for I want to say like I don't know like probably $5 on Amazon for like a kit of like 40 of those little wires. But the little female connectors, make one a 2-pin and the other two are just single pins, so you can distinguish between the LEDs and then the actual power button switch. Those are 4 wires you have to wire up, and then everything else will just work perfectly fine. I also had to modify this front panel here. This is another 3D printed part. The way I designed this, I went in and took measurements of the entire width here from side to side, and I also took measurements as reference points to these little 3 holes here that correspond with these 3 holes on the front of the front panel. Here, here, and here. This allowed me to get all the measurements I needed exactly to mount that up, and then also I just grafted in the measurements of a 140mm fan for the holes. That way I could just 3D print this and basically place it on there, use these holes as references, plus lined up with this side panel, this back riveted on like piece right here for the case, and then you have your stencil where you can cut out the middle, and then you can also just mount up your radiator, fan, whatever you have to the front here. Now, mine's a lot more crude because I originally had, different iterations of this. First, I had like an AIO 120mm AIO mounted to the front, and then I moved up to 140mm fan, and then so on and so forth. So I cut out more material than I needed to, and that's why you're going to see a little bit of like warping here. There's no like metal reinforcement behind these screws, which allows it to kind of flex. But if you like were to buy this case, I'll do it over again. I just reprint this, make that stencil with like a Sharpie, cut out just that centerpiece, and then the rest is just reinforced metal behind it. So you're not going to get any of this flexing on the actual front plate for the mounting of the fan, and you're going to get a lot more rigid stability. Now, I'm not saying this is weak, with the epoxy job I did on here, and this front piece is like 3mm plastic, and I bought this from Xometry using one of their higher quality 3D printed plastics, so it's not going to break on me. But yeah, that modification allows you to mount a 140mm fan in here, which is great for intake if you want to have like a small air cooler in here. Once a 140mm fan will get you plenty of fresh air for your graphics card or whatever, but also it allows you to mount a 140mm radiator like I showed before. I also had to modify a little bit of the drive bay. I had to like kind of bend some of the reinforced metal that's supposed to hold the drive cage in place, um, just so I could slide this in and out fairly easily. But that's pretty much all that is said about this specific system. Um, so yeah, guys, on the inside, this thing is pretty freaking insane. But overall, it's on the outside looks pretty much like a normal Dell OptiPlex that you would have bought back or seen back in 2013. And overall, I'm really happy with this. It definitely was a challenge. I probably spent way more money getting this put together than I would have just building a normal PC and even a micro, I could have built like a mini ITX small form factor workstation that had similar comparable performance to this with modern hardware and save money. To be completely honest with you, but this was a challenge. This was something I wanted to do just to push my building techniques, take on the different problems of, okay, what components do I need to buy specifically to get this specific CPU to work in this specific case. And there's a lot of different, iterations of this over the years, over the year and a half that I built it. But I've gotten it to a point to where I can service it and it's reliable. I probably will be posting when I get my gaming PC finished. All I have left for that is like the graphics card, like I said before, and then like a different SSD to throw in that. But I'll make a video on that specific PC, and then eventually, when I get to my a couple years in the future, when I get all that stuff set up, I'll show you my entire gaming or just desktop in general, where both these systems are in tangent. But yeah, just a couple things about 95% complete. The RAM and then the bigger SSD to get more storage in here, and then this thing will be pretty much done. So hope you guys enjoyed the video, and I'll catch you in the next one.